So you might be asked to generate an equation from some details that you've been given, but which form of an equation do you select, and when and how? Hi, my name is Mr. Brash. This guy over here is Mr. Squirrel, and we've been doing some math videos for the last little while. And I'd like to go over how do we generate an equation for a parabola or quadratic in order to have the mathematics behind a situation or a graph. Now, what do you need to know about parabolas or quadratics up to this point? Well, if you're watching this video, hopefully you know the three different forms and what you get from all three forms. Standard form gives us the y-intercept, gives us an a value that has a lot of properties for us, and what you're going to see in a bit is it gives us more information than what meets the eye. Factored form gives us our zeros, which are known as the x-intercepts, also has the a value, very useful. We can calculate a y-intercept if we needed to. Vertex form gives us the vertex with the h and k, still has that a value, and also we can generate the y-intercept if we needed to, and we can solve for the zeros, and we can solve for the zeros pretty much in all three of these forms because of some of the tools and skills that we've learned. So at this point, we need to know the difference between factoring and expanding, and when we might use one versus the other. The axis of symmetry of a parabola is super important. It is the halfway point between the zeros. Or really, if you have any two roots, it's the halfway point between them. It doesn't just have to be the zeros, but it is this idea of an average. We should know how to complete the square. That's what gets us from standard form to vertex form. And completing the square is what led directly to the quadratic formula, which is what we use to solve for the zeros when things aren't factorable. From the vertex formula, from the quadratic formula, what we get is the vertex formula. This is the x value of the vertex from standard form. And the discriminant is the other piece and tells us how many zeros we're going to have, or if we're even going to have any zeros at all. So if I give you a graph of a parabola and I give you some information on it, perhaps I give you a parabola that opens up like this, I give you the vertex and I say, okay, that vertex is at 5, 3. And then I give you some other point on the parabola, and maybe I give you the point 7, I don't know, let's go 7, 7. How would I generate an equation for this parabola, and which form of the three forms do I select? Well, right off the bat, I'll tell you that standard form is not very useful to go directly into. You're not going to take some facts or some information either from a graph or a scenario and go straight to standard form. It's just not something that's typically done. Factored form, because it deals with the zeros, we are going to only start into factored form if we are given our zeros or given two roots that are very valuable. Vertex form, exactly in the name. We're going to use this when we're given the vertex. So in my little drawing right here, I would know that I should really go into vertex form. Even if the question asked for the equation in factored form, I can't go into factored form with this equation. I can really only go into vertex form. What you're going to do is you're going to set yourself up. You're going to start with your typical vertex form or whatever form you chose, and then you're going to plug in values that were either given to you or you have. For example, I was given that the vertex is 5, 3. So what I could do is put the 5 right in there, and then I could have my 3 on the end. And there I've got my vertex in there. But how do we complete the scenario? What we really need in most of these situations, pretty much every time that you've been asked to generate an equation, you're going to be looking for the a value. You want that amplitude. How do we get it? We've been given another point in this scenario, this 7, 7, and that's the crucial thing. This is an x and a y that we can plug into our equation to solve for the a value. And so if I put a 7 in both of those locations, the y and the x, just so happens that, I chose a point that is both 7 and 7. Now we can start doing the math that would solve an a value for us for this particular graph that I just completely made up on the fly. 7 take away 5 is 2. So this is 2 squared, which is 4. So this is now a times 4. I can subtract 3 on both sides. When I subtract the 3 on both sides, 7 take away 3 is 4. When I take my 7 minus 5 and square it, I get 4. So it just so happens that the quadratic I made, this is really interesting. I divide both sides by 4 and I get an a value of 1. That's incredible. I actually made that by accident. And so because I have an a value of 1, my equation in vertex form is nice and simple. X minus 5 squared plus 3, and I don't even really need to put the 1 out in front there. But that is my full equation in vertex form of this parabola. If I then was asked for factored form, I would have to find any zeros. Now there are none. Or if I was asked for it in standard form, I would expand it out. So those are the sort of the things that happen based on the skills you already know. Let's take a look at some more examples. This is one of those situations where I can really only teach this with example after example. So I don't really want to go over too many, but check out Khan Academy, all those other things. And when you get a scenario in one of my examples here, pause the video and see if you can figure it out yourself. Here in example 1, a parabola has the zeros at 1 and 2. So right away, you've been given the zeros. So what form do you know you're going to want to put it in? Well, you're going to want to put it in a factored form because factored form deals with the zeros. It's that simple. It's not some magic detective math or anything like that. We know what the three forms give us, and so we go with that. It says to give an equation, so it doesn't really matter what form. So no form here was specified. No form was specified. And that's great because we can just go ahead and do whatever form we want. But let's read the rest here. Give an equation to model all possible parabolas with those zeros. What does that mean? If I have a Cartesian plane here and I plot my zeros, so 1, that's a 1, and 12. There we go. I don't know if this parabola opens up. I don't know if it opens down. I don't have another point for this parabola. What we can have is all sorts of parabolas. I could have a parabola that opens down and has a vertex right about there. I can have a parabola that opens up and is super, 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 super tall like this. And I can have maybe another one that is not tall at all and goes like that. And because we've been given that freedom and the only thing we know are the two zeros, the idea here is we really don't know what the a value is. And we're not going to be able to solve for the a value. We are going to have an equation where the a value remains a variable because it says for all possible parabolas with those two zeros. We're going to plug in our zeros, 1 and 12, and we're just going to leave it at that. We don't know what a is. That is the equation right here that models the parabola with these two zeros that just, it's an infinite number of possibilities. Moving on to the next example. When a golf ball is hit, it lands 220 feet away. So I always like to draw a scenario for myself. I'm a big fan of sort of this visualization. So I've got this ground and I've got a golf ball that starts right about here, and I'm going to hit that golf ball. Hopefully the golf ball travels upward and I don't get a bad shot or whatever. And when it lands, wherever that happens to be, that's 220 feet away. I know that spot right there is 220 feet. What does that mean about the first one? Well, if the first one is where I hit it from, and this is where it landed, I can really say that this is 0 feet. Because in order for this to be 220 feet away from where I hit it, I need that full distance of 220, so this is 0 feet. I haven't even finished reading the question yet, and I know this parabola opens downward. I know I've got zeros at 0 and 220. Let's keep reading. It reached a maximum height. Maximum happens at the vertex. It reached a maximum height of 121. So that's a height of 121 right there. At a horizontal distance, horizontals left and right, at a horizontal distance of 110 feet. Now that makes sense because that's halfway between 0 and 220. So that's going to be my vertex. So I know I wrote right now, I've got vertex. I know my vertex is 110, 121. I know my zeros. My zeros are 0, 0, and 220, 0. And the question says, construct an equation to model this situation. They didn't say any particular equation, standard form, factor form, vertex form. I get to choose. And the beautiful thing is, now I get to have either one. I was given the vertex and I was given the zeros, so I get to choose. Let's say we go with vertex form. So y equals a, x minus h. I really find it helpful to write out the generic form and then just plug in our values. So here's my h and here's my k. So y equals a, x minus 110 squared plus 121. And then I need to figure out what my a value is. That's pretty much always what we're looking for. I need another point, not the vertex, a different point that I can plug in for x and y. I have two more. I've got my zeros. And so I get to pick which one of these I want to put in. I'm going to put 0, 0 in because that's really easy to use, but I could put 220, 0 in and I'll get the exact same answer. So I'll put my 0 in for my y, put my 0 in for my x, and I'm only doing that because 0, 0 was given to me, not because I just want to plug in 0 and 0. I do find that a lot of students just make x 0, or just make y 0. You can't just make them 0 willy-nilly. You have to be given those. So what we're going to do here, we're going to subtract 121 on both sides, so that's negative 121. And I'm going to take the 0 minus 110 and square it. So 110 squared is 12100, 12100. All right, last but not least, we're going to divide both sides by the 12100, which gives me negative 0.01. And as much as I don't like decimals, we're going to leave it a decimal. We could have done a simplified fraction, absolutely. I'm just going to leave it as this. And that means that my equation, just quick therefore statement, that my equation is going to be y equals negative 0.01 x minus 110 squared plus 121. That is the vertex form of this scenario. Does it make sense? Well, I have a negative a value, so it's concave down. That's great. I have a very, very, very small a value, which means I have a sort of a fat parabola, and this is a golf shot, and it went pretty far. So yeah, it's a fat parabola, or maybe a short parabola. I have my vertex in here, and everything looks good. What if I wanted to do this in factored form instead of vertex form? Well, I would start with my factored form, and I'll plug in the values of my zeros for the r and the s, and then I just have to have another point that I can plug in for my x and my y. So I need an x and I need a y, and it can't be the zeros. I've already put those in at 0 and 220. Well, I have another point. It's the vertex. My y value of the vertex is 121. My x value of the vertex is 110. And watch what's going to happen. I'm going to have 110 times 110. Because 110 take away nothing is 110. And 110 take away 220 is negative 110. I have a 121 on the left. Look familiar? We had to square 110 over here. I had a 121 on the left. So 110 times negative 110 is negative 12100. I'll divide both sides and get the exact same a value. Negative 0.01 is my a. No surprise there. Just confirming that it worked. You don't have to do both versions of the equation. I'm doing both versions of the equation just to show that it works. Whew, almost ran out of room there. So now I get to choose. I chose either one, and it really doesn't matter. Moving on to our final example, a test rocket is launched from the top of a 12-meter platform. I always like to stop reading and draw a little scenario for myself. So I've got this platform right here. This platform is 12 meters up in the air. So that's a 12-meter tall platform. And my rocket is going to be fired from this platform. It reaches a maximum height of 72 meters. So that's actually much higher than 12 meters. So it's kind of up here after 10 seconds. So I know that this is 10 seconds, and I know that it's a height of 72. So let me just write that over here. 72 is that height. And presumably, that's going to continue to fall until it crash lands somewhere on the ground. That's my rocket. It's not like the Falcon 9 that can land on its own. And so we might say that the ground is like that. Okay, there we go. And it lands on the ground. And that would be one of my zeros. It says to give an equation in standard form to model this situation. Well, I gotta tell you, I'm not going to go straight to standard form. There's really no way to do that with the given information. But I do have enough information to put it into vertex form because I was given the vertex. The vertex is 10, 72, a height of 72 after 10 seconds. So I can go directly into my vertex form, x minus h squared plus k. And now I need to plug stuff in. Well, let's plug the vertex in. Plug it in, plug it in. If you've watched any of my other videos, you would have heard me sing that and understand why. Now I need to find the a value. Again, that's what we're always looking for, is the a value. I need another point to plug in here. And it's not blatantly obvious what that other point is. I know I have some 12 here. When would the 12 occur? The rocket was launched at a time of 0. Pretty much all of these scenarios occur at either a distance or a time of 0. You wouldn't start the stopwatch until the rocket actually launches. So this is the point right here. This is the point 0, 12. That rocket was on top of a platform, and at 0 seconds, it was 12 meters high, and then it was launched. So I have another point that I can plug in. I have an x of 0 and a y of 12. So 0 take away 10 is just negative 10. We're going to square that and get 100. And I'll just do the algebra. So we're going to subtract 72 on both sides. 12 take away 72 is negative 60. 10 squared is 100, as I mentioned. And maybe this time I'll do simplified fractions. So negative 60 divided by 100. That's going to give me, 6 over 10, which is 3 over 5. So negative 3 over 5. You're more than welcome to put that into decimal value if you prefer. And so I've got my equation. Yay, I'm done. Negative 3/5 x minus 10 squared plus 72. But unfortunately, I'm not actually done. They wanted it in standard form. So I've got now to do a little bit of work. I'm going to multiply all of this out. So I'm going to expand that binomial, which is squared. There's a trick for that. Square the first one, multiply them and double and square the last one, or you can go right ahead and expand it all out yourself, FOIL it out, or whatever it is you've been taught to do to expand that. We'll multiply that negative 3/5 in, and this is where I might wish that I'd turned it into a decimal, but let's be strong and keep using the fraction. So 20 times 3 is 60, 60 divided by 5 is 12, so I'll have 12x, and then 3 times 100 is 300, 300 divided by 5 is 60, and so that gives me negative 60 actually, negative 60, and I just have to add the 72 on the end now, and so my standard form, my final form here, negative 3/5 x squared plus 12x plus 12. And this is, of course, assuming I didn't make any algebraic errors here. And if I made some sort of calculation error, I was doing this in my head, so I do apologize. Hopefully that's correct. You can, leave me a comment if I made a mistake here. And there I have it in my standard form. So that was the answer to question A. Question B, when will the rocket hit the ground? Now that I have two versions of the equation, I can choose whichever version I want to use, and I need to decide at what time, so this is a time here, when did the rocket hit the ground? Well, that's a 0. I'm looking for the zeros. I need to decide how am I going to solve for the zeros in this equation. I can use the vertex form and just solve it, or I can use the standard form and try to factor it, use the quadratic formula, or I could also use the PQ formula that we've learned in one of my other videos. Now, if you don't know the PQ formula or the way that I did in that other video, that might not be handy. So let's take a look at that vertex form. The zeros happen at a y of 0. So this is question B. So I'll set my y to 0. I've got negative 3/5 x minus 10 squared plus 72. I'll subtract 72 on both sides. And as always, you can pause this and try it out on your own. I'm going to have to multiply by 5 and divide by 3. 72 times 5 is 360, and I'll take the negative with it so that it becomes 360 on the positive spectrum. That's still equal to 3 times x minus 10 squared. I'll divide both sides by 3. 360 divided by 3 is 120. And now I will need to square root both sides. This is where it gets a little bit messy. Square root of 110 is approximately 10.954. So 10.954, and that's approximately equal to x minus 10. And of course, because that was a square root, I've got a plus or a minus. Okay, so we've got two zeros, two scenarios here. We've got positive 10.954 is x minus 10. And so I'll add 10 on both sides and get 20.954 as an x value. And that's when the rocket may have landed. Or I've got negative 10.954 is equal to x minus 10, and I'll add 10 on both sides. And when I do that, I get negative 0.954 0.954. Well, I'll tell you right now that the rocket did not land at a time of negative 0.954. We would actually call this inadmissible. It's not a correct answer. So this is where the rocket landed. Ooh, right there. So this is where the rocket landed at a time of 20.954. Does that make sense? You got to ask yourself, does that make sense? Well, it got to the halfway point at 10 seconds. So does it make sense for it to be landed, at 20.954 in terms of time? And absolutely, that makes sense. 10 seconds to the halfway point, another 10 seconds plus a little bit for it to land, because technically speaking, my other zero is over here at negative 0.954. So it makes total sense. And I give myself a little therefore statement, therefore the rocket landed after 20.954 seconds. And there you go. All of that was garnered and created from a little tiny bit of information in the question. Now, of course, I went really fast. In order to try to keep my videos pretty short, I tend to go pretty quickly. But pause it, rewind it, view it again, check out a Khan Academy video, and you gotta try these things. You gotta find some practice questions out there. Hopefully a teacher gave you some homework from a textbook, or you use an online textbook or something like that to practice these questions. Feel free to give me a like or a comment or anything like that. If you're going to give me a thumbs down, leave me a comment and tell me why you're giving me a thumbs down. I'm not a big fan of the thumbs down for no particular reason. Let me know why, and then I can fix my videos. If you want to subscribe to my channel, go for it. I'd appreciate it. This is Mr. Squirrel. He approves this video. My name is Mr. Brash. Have yourself a wonderful day and keep practicing math.